Same slide. Okay.
Hi everyone. First of all, I'm Vijay Ganesh. I'm currently working in Tata Consultancy Services as Hadoop developer. Also, I work on proof of concepts on machine learning, natural language processing, and other things like that. So, I'm first of all sorry for coming late. I had a small work somewhere, so yeah, I had to travel like 70 kilometers today morning alone. So, I really apologize for coming late. So, how are we? I mean, like.
We have some people over there and we go to meeting also.
All right, cool. Hi, everyone.
Not limited.
Okay.
But we can.
Okay. So Manikandan would have told you about the what is R and everything. Can you just tell me what someone can elaborate what he told? Like what was the thing was discussed?
We just started the machine learning.
Oh, super.
We started learning about the big data.
Okay, cool.
Hadoop.
Okay.
What is Hadoop? How things are working?
Okay.
What is the map reduce?
Okay.
What is the what are the HDFS?
Alright.
Then we started with the machine learning, natural language processing.
Okay.
How the Google now is working.
Cool.
Then that's where we started, and then we have just using super.
Okay. So have anyone here used programming languages like R, Python, Scala? Other languages. Okay. I'll start with the difference between conventional procedural programming languages and functional programming languages. So Java, C++ are there, right? They are really difficult to learn, and people have moved away from them. The conventional, like the production codes, codes which are there in, I mean, like to get ETL things, those things are in Java and C++ and whatever. But coming to the whatever is coming nowadays, it is everything in functional programming languages. So functional programming languages are like R, Python, Scala. So the main advantage of the functional programming languages are like the syntax is very simple. It is almost close to human and not natural language. We don't have declarations. We don't have. Actually, I have my laptop. Start with this paper.
I can. You take it. I can.
There it is.
And you go to the make it to this one. Okay. So that you can use the coding. Because that is recording. Yeah. Okay, give me 2 minutes of time. We are connecting the R programming, R software. But my mic is not working. Okay. So Wi-Fi connection. Okay. Go to the link. To the makeup center. To the makeup.
So when they are here, can you please introduce
Yeah.
who we have?
I am working on it.
Okay.
And this was interested in other projects.
Okay.
Yeah.
Okay. Okay.
Yeah, this is someone here, not the leader or analyzing Dinesh Kumar, I'm from Simulation Software. We are developing a toolkit like Cloud or Super. Similarly, we have a toolkit to create clusters. Like they have sandbox, we have a software called Studio. In that we can perform things, everything. Okay. So it was like breadwinds. Okay. We are covering. Okay. And not in depth. So I like to go in depth. So I'm interested.
So, have you done anything in machine learning or Python?
I'm not that part of it. I was in the implementation.
Okay.
So like everything will be done by some other team.
Okay.
I'll be integrating in Visual Studio.
Okay.
So I'm developing a product. Go to meet that. Go to .me slash Bigdata capital B underscore R. Okay, guys, whoever is in the online, can you just introduce yourself quickly? What do you want? No, it's not. Five six. 5 6 D Nash MU. Wait. 5 6 J man MU. G7 all both the all of them. Guys, is there audio is back? Are you able to listen?
Yes, now we're able to listen.
Okay, I just introduced Vijay Ganesh on this. During that time, the voice there.
Yeah, it was there.
Perfect. So he's about to showcase the R software from his computer, R software and the machine learning software from his laptop. I'm going to make him as a presenter for a moment. Okay.
So now I guess you must all be able to.
Yes, we can able to see this.
So, so just like any programming languages, you must first install R in your computer. So R you can download directly from the CRAN repository. And just like how Maven is maintaining Java chars. You have heard about Maven, right? Similarly, R repositories, R packages, or everything are maintained by CRAN repository. So you can download R directly from this those other websites. And just the installation setup is almost similar if you're using Mac, Windows, anything. So this is where you should download R. This is the, I mean, like with this you can do command line operation. But generally for developing application, we may need an IDE, right? Integrated development environment. For that, we have something called as R Studio. The R Studio console, you can see. This is R Studio console. This is how it looks. Everything is open source. In R Studio, when it comes to R Studio, everything is open. There is the yeah. So this is how R Studio looks like. The installation is straightforward. Nothing, no confusion. Just set up next that. So these are all the four main windows that we have in R. The most important four. So this is where you write your code. This is the text editor, and here we have the command line. So while we are prototyping something, we may write a code. At some point of time, we may need to check whether this snippet is right working or not. So that we can just, for example, I have written two code, something like that. I can run it in command line using this. So just whatever we run here will be displayed in this console. Okay, so this is the one on the right side. The first topmost column is the environment variable. So whatever we declare, whatever we instantiate, everything will be displayed there. I mean, like, so this is like if you have used Java, C++, we need to run a separate debug module if you want to compare to see what is happening during the program flow. But those things you can directly see here. So, and this is the I mean, like the file, what all the files that are available. Our current project location, those things you can see here. We have the also if you plot something, those things will be displayed here. Packages. I'll tell about packages later. So those what are the packages that we have installed? I mean, we have downloaded. Everything will be here. Also, R has very good documentation. So you can either go to CRAN repository or even here. Whenever you download a package, all those documents will be available. You can just go through them. Since it is all open source, there are lots of contributors for R, and it is growing a lot. Also, I would like to say one thing: if you already know Python, you can do everything you're doing in R in parallel in Python. It's not necessary that you need to learn R separately. There won't be much difference between R and Python. Just that it is different. I'll tell you the history how R started. So they become our two branches. But whatever you can do it in R, you can do it in Python, and whatever you can do it in Python, you can do it in R. No, it's not the same code, but the same logic I'm saying. The syntax will be different, but at the end of the day, we'll be doing the same thing. The number of steps will be the same. That's what I'm saying.
No, but it will support Python. Right? I can use the Python code.
No, you can't do that. No, you can't do that. You can't do that. And what I meant to say was, it is not that R is superior, Python is superior. All the functionalities are available. The coding will be slightly different. So that is what the basics of R.
So do you need to learn both or one?
It is you up to you. I'll tell you the perks of learning both. R is hardcore statistical language. It will be respected more when you do something like data mining, data analytics kind of things. Also, if you want to visualize data, for those things, R will be respected a lot. But on the other hand, Python is a universal language. It can be used for everything. You can do image processing in Python. Have you ever heard about OpenCV? Open source computer vision. There is a tool OpenCV. That one you can do in Python. Even TensorFlow code, right? That one you can code in Python. Spark you can code in Python. So Python, on the other hand, has its own code. If you learn Python, you can do a wide array of things. So R, if you want to do learn only, like data analytics part, if you want to go, you can go for R. If you want to cover a wide spectrum, you can go for Python. But the learning curve for R will be quite easy when compared to Python. So it is all up to you which one you are. But once you understand R, Python is very easy. That's what I mean.
Is that something like R is fast and Python is fast?
It depends. All depends upon the how we write the code, what kind of complexities we use. Everything is going to when we run it on the same hardware, both is going to be same. But there is a belief that Python is quite faster when compared to R. There is a quite belief, but for what we do, we won't see much difference. So coming to R,
What do you mean?
okay, yeah,
Sorry, small intro for
okay, from mission management.
you want to simplify?
This is my slide, right?
Yeah. We have to make it.
Okay, yeah. Oh, they also have. We have to do
Yes,
it.
another one. Okay.
They are recording, right?
Yeah.
Okay. So ask what is machine learning, right? I'll just say. So this computer is a dumb machine. It doesn't know anything. What we tell, it understands. Correct? Without writing a single line of code, it can't do anything. But what we are trying to do is, instead of teaching all the things, we'll teach few things and we'll make computer to understand. So, for example, when we were kids, when we were really little babies, how did we know to speak? How did we know to write? For example, we have a letter A. How do we know that letter is A? So we saw the letter A. Someone told us this is A. We made a mistake that this is not A, this is B. Someone has slapped us and told this is A. Understand? So that is how we learned A, right? Similarly, we'll do the same. We'll say a computer that see here this letter is A, this letter is B. We'll give all the 26 letters and we'll again test the computer whether it is understanding the A correctly or not. If it is not understanding the A correctly, we'll say you are making this percentage of error. Then we'll again try to minimize it until then it can understand A to Z. So that is the basic concept of machine learning. So that is how. For example, this thing has a wide array of applications. For example, this has actually happened. There was a bank in US. So a person opened an account and he lived in Northeast. I mean, like New York, those kind of areas. So what happened is he was a fairly healthy person. He used his credit card to swipe to gym. Also, he always buys food in organic shops, everything like that. So, and he lived in Northeast. One day, what happened was he traveled to Southwest California place, and he swiped his credit card in McDonald's. Immediately, his credit card blocked, and he got a message that we suspect that this is a fraud transaction. Uh, so that person immediately called, why did you say minus a fraud transaction? Then they immediately unblocked it. But after when they broke down what happened here, they actually had a machine learning model. So what this model did was, it has characterized him as a healthy kind of person. They have moved him to that cluster. He was in northeast and he is in southwest. In one day, before that he has swiped there. Immediately after, there is almost like 4,000 miles, a new swipe has happened in completely different genre of food. So immediately it happened. So these things computers are started to learn. It has able to. I mean, like even if we have the data, we can do it sitting here. That is the power of machine learning and open source. So one example is that one. Another example I can say is everyone would have stopped in e-commerce websites, right? Flipkart and things. When we buy a mobile phone, immediately it will suggest cover. So how does it happen? So this is called recommendation engine. This is another application of machine learning. So other things I can show. How many of you use Google Photos? You see Google Photos. How does it tag the individual person? Also, if you are, for example, you take a photo from in a forest background, it is segregated into forest, trip, sky. If there is a car somewhere on the corner, it will say this photo has car in it. How is it doing? This is also a machine learning. So, machine learning has wide variety of applications, and I'm pretty sure that that will be the future. So, when I came in, I saw different types of machine learning types of going on. So, yeah, Google IoT, Google Lens. You heard about Google Lens? Yeah. Google job portal was there. Even that was the application of machine learning. So,
it is totally different way. Again, if that is focusing only, I know .NET, Java.
yeah, everything will be outdated.
Oh, you are 20 years back, hey, today.
Now everything is moving, pivoting towards artificial intelligence and machine learning, big data, cloud. So I read somewhere that if you want to survive in the next 10 years, you must know either artificial intelligence, cloud, big data, or all these three together. Only these three will have. And one point of the time, all these three will meet. Pretty soon, it's all going to meet. Even now, I can say that IBM Watson is there, Microsoft Azure is there, in which already AI engines are present. So it is a cloud which has AI. It also has big data capability. So everything is already met. So now is the right time to, pivot towards from the conventional what we was going to. Uh, so can we go technical or can we discuss more about the real-time applications which we are having?
Yeah, we combine both.
We combine both, right? Yeah. So another example, what I can do is. Uh, okay. Do you know about Google Vision API? There is something called Google Vision API. I can show you real-time examples of how it is done. Also, these things are available open source. I'll take it. I'll take the. Okay. Before going to Vision API, let me show another real-time example which is happening in our back. So tell me, anyone here, tell me a Facebook account. I want to start correcting. I just need a picture as the okay.
Yeah, going to Because I never opened the Facebook for last one.
Okay, let me show mine. So,
you are the one who told, right? I enter, the other side talking. Now you are giving 10 to carry, we can. Yeah, the machine learning algorithm, whatever password is, the machine will understand what is the password you give for next 10 years later. That will predict you. Random thing. What is the password you will think for next 2018? That will detect. Okay. He is a guy, he will give the password. This is the way password only like algorithm. No, it will take for last 10 years of a password pattern. He given password pattern. Okay, now it will give you password only. So now given try to
here, one real-time example. It is happening in our backend, which we are not aware of, but it is happening. So this is my Facebook profile picture. When I give inspect element, so I was just going through what is happening in the backend. So you can see. So see here how they are describing my image. Can you see one person standing, sunglasses and outdoor? Can you see that? So whatever image you are, can you now can you see?
yeah.
You can go and try this in any of your photos. It is automatically getting tagged. Image may contain one person standing, sunglasses outdoors. For example, if there are 5%, 4 are wearing sunglasses, it is tagging. In the back end, this one is happening.
Guys, whoever is in the online, are you able to visible?
Yes, Manu, yes, sir.
Giving the steps. That is why this is alternative text. So people who are know HTML, they can understand alternative text. So this tick is happening.
These things are all done outside, right? In training.
So
That's a big data community. Yes,
actually, you can implement this real time. If you have TensorFlow, Facebook is using something a different tool. It's called Cafe, CAFFE. If you are interested, you can explore. But similarly, Google can also do this.
now Cafe 2
Cafe 2 has Facebook really launched this. So with TensorFlow, we can do it on our machine, sitting somewhere in our Paris, we can sit and do it. So this was one example. So how this is happening? So if you are not interested in coding and if you want only this application, there is also an API provided by Google Cloud, Google Vision API. It's called Google Vision API. I mean, like Ravi has asked the question, what is the tool name?
What is the tool name?
Tool for?
You told Facebook tool. Cafe 2.
Hey, you told about the tool, right, for Facebook. What is the name?
It's Cafe. It's a framework. It's not just a tool. It is a set of libraries
Oh, okay.
given. You can code Cafe using Python or C++.
Okay, okay, okay.
Why is it? So if you want to implement this, whatever I showed you before for your application, for example, you can build an Android app, take a photo, and if you want to describe it, you need not write the entire code. Google provides an open source API. Okay. Before this one used to be without credit card, now it's asking for credit card. I'll show you another. Google has Vision API, right? Amazon has something called recognition. So sorry for pivoting from Google to Amazon, but everything is the same. That what their core business is the same, the tool is different. I wanted to show the demo, but recognition. I don't know why it's mentioned. So tell me any image. Okay, okay, you can even search this. Sorry? Very good. Yeah, you can do it. Okay, any more suggestions? So, shall we take this image? Okay, let you have this image. So, this is the sample image they have. See here, this was the image that was updated. See, it has been tagged. This one has a skateboard. This is the image of sport. People are there, person. There is a human. It looks like a parking lot. There are automobiles, car intersection. Look at how it has tagged different things. So now we'll go and try our own image of Marina Beach. Here it has said with beach, outdoor, freeway. Here it has even identified that this is an aerial view. Actually, if you do Google Vision API, since they do page crawling, they can even say this is Marina Beach. This one looks like Marina. Vision API can do that. AWS can do that. But on the other hand, recognition has a powerful page comparison. You post only one image of yours, and it can detect different angles of your face. So what I tried was Ajit, after Ajit, I tried his childhood pic. I mean, like teenage pic. Then I tried his new Vivekam poster. It gave a match that this guy is there. So that is how the technology is getting today. So enough of this examples like this. Uh, then we'll go to yeah. So okay. So was it interesting? What we want to do? What they did, right? So let's start from step by step. For knowing machine learning, we must know how to communicate effectively with the computer to understand. So we'll learn first R. So what? How R everything is done. Before that, so someone asked what is R. So this is the thing. It was done by two people, Ross Yahaka and Robert Gentleman. Their name started with R first. So some people also say that there was before a statistical language called X. So next to that it came R. So there are two theories how it is named, but the second one is the. So the main reason why R is trending is it has a great visualization tool. You can create visualizations like this. This thing is done entirely using R. So what this picture is, how who is the weapons exporter and who are the importers, from where the weapons are flowing. Actually, the data is quite simple. It will be a CSV format, 200 rows, 4 columns. When we see the data, it will become mad. But look at how they have creative visualization. This thing we can do it with like 40 lines of code. This thing is possible. Just 40 lines of code. That is the power of functional programming languages instead of procedural exam.
Same you can do in Python.
You can do it in Python, but here it is straightforward. Like if Python has lots.
Python has a representation tool.
You can do it. There are
Other
tools.
tools.
Yeah, it depends on other tools. Correct. You can call D3JS, JavaScript, some integration, something like that. But this one directly has download a package and do it. Even Python has IPython or do Python in which you can do it. But this one, I feel, in my personal opinion, R when you want visualization, R is perfect. ggplot2 and for getting the map there is another I forgot the name. I didn't make this. It was done by another person, but he has made it open source. I mean, you can see this code. You can download the data and you can make ggplot2 was there, and also one more thing was there to plot it on the map. So also it has another data set in which when you have a country, the center will be you can see everything is starting.
What to do?
Okay, Tableau is exclusively for visualization. You don't want to code; you just want drag and drop code. Even R little amount of coding, but even if you don't want to do that amount of coding, just take a click a source, take the source, connect it. Then in the visualization, you can just take preloaded things. You can go for Tableau, click view, things like that. But here with R, you can play around. You can go to front end, back end. You can also. Also, R has a great tool called Shiny. R Shiny. With that, you can create an interactive visual. So this is done using R Shiny. So with this, you can I mean like interact with R. Can you see? So we have the sliders, pointers, drop dogs. This is done entirely using R. You can even publish this on internet. You can take a data and you can make user query data. This is done by R Shiny API. So these are all the visualization part. Coming to the part, what are the things we can do? R basically is a statistical programming language. Mean, median, mode, standard deviation, everything. That is where our foundation lies. Even for data analytics, the foundation for everything lies in the statistical mean, median, standard deviation, variance. So with R, the primarily you can do those things. If you have a data set, you can explore the data totally. Then you can do text analytics. Text analytics is personally my favorite, which I have been working in a company for past years. So, for example, an interesting application is based upon a person's tweets. Social media, you can monitor a person, and based upon how he tweets, you can fix the insurance premium. This is actually happening. I worked on a project, and this is where it happens. For example, if a person has a lifestyle like he smokes, he drinks regularly, so we monitor his tweet profile with his permission. So what we do is we create an app application for insurance. So, for example, how many of you have any bank account? You installed a mobile application, right? Unknowingly, you would have given permission to access your data. So, we have given permission. So, they will crawl through our data. So, when we post things like that, they can, understand. So, this person is a smoker. So, when we give a health insurance, our premium will be high. So, this is actually happening. This is based on text analytics. So, machine learning is there. You can do, which will be covering. The next one is integration with Hadoop. So, Hadoop and R have a close, since it is both are open source, there have been packages to interact between both. You can even write a MapReduce code using R. So, if you don't know MapReduce, so the MapReduce code you can write using R. Just download the packages and you can write MapReduce code in R. Things like that. You can even run Spark in R. H2O, I guess you were saying, even H2O you can run this R. So next one is image processing and recognition. I would say this one with R it is not that much mature compared to Python, MATLAB, things like that. R is not that much mature with image processing. Signal processing kinds of things are always there for people with core engineering background. They can even do signal processing, filtering, things like that using R. So can we dig deep into R like data types, things like that? Because we are having 15 minutes. I show that will be enough. Okay. You can go right. I'll go pretty fast. So what are all the data types? So these are all the basic data types: numeric, integer, complex, logical, and character. There is no string. There is no float. This is the basic data type. So again, I will take the
Logical data, right?
Boolean.
Brilliant.
So let me just give an example for everything. Okay. So tell me what was the first variable? I've taken control, right? But we So what was the first data type? Okay, before going to that, let me show you how to assign variables, basic syntax and everything. So A, for example, A you want to assign it to 5. That's it. A, okay. Okay, is 5. Also, you can do like A equal to 5. That will also work. But I personally prefer A. It become a habit, so it become a thing. The interesting thing is you can even make.
You don't need to declare it.
No need to declare. Nothing. Just A equal to 5. It will internally type that. So this is my favorite part in R. You can even do this. 5 is A. So if you want to see what is A, you can see in the here, right? Can we zoom out with this?
No.
இல்ல அது ஆர்ட்ஸ் ரோம்ல தான் பண்ணிட்டேன் நான் இதுல பண்ணல எனக்கு ப்ரொஜெக்டர் சும்மா இருக்கு Okay, now you can see in the environment the thing we assigned came A is equal to 5. So this is environment, just like debug control. Similarly, if you want to assign something like A is equal to hello, you can see A has changed to hello. So this is how we assign data in R.
Online people are able to listen, are able to watch.
Hello.
Yes, ma'am. Yes, ma'am. Okay.
So similarly, if you want to assign something like, okay, now we have assigned A is equal to hello, right? We can check what is the data type of it. So we'll give class of A. If you see class of A is character. Okay. So for example, now we'll assign A is equal to 5 again. Now we will assign A is equal to 5. Now we will give class of A. So it will come as numeric. Now we'll give A is equal to 5.5. But still it will be numeric. So we can say integer is like int data type. Numeric is like float. I will say float is like that, but it is not actually. Default is whenever we declare a number, it will be going to numeric only. We have to internally cast it if you want it as integer, but those things we generally don't do. We don't care what data type it is internally being. So if you want to, for example, if you want to actually declare a variable with integer data type, you can give A is as dot integer of 5. So when you do that, it will be actually typecasted to integer data type, and you can see there is a L next to it, indicating that it is an integer. Long, okay, long integer. Because in I it has complex. For example, I told you right, there is another data type called complex. For example, A is 4 plus 5i. In that case, I will be used. That's why it's a complex number. So that's why I is not used. Instead, L is long. So you can use complex operations also. Next one was Boolean, right? A is equal to everything must be constant. So A is equal to true, you can do that. Or huh? Yeah. Also, you can do just capital T. Both are true. You can check class of A. It will say logical. So we saw how to declare all those primitive variables, right? These are numeric, integer, and everything. This one is logical. We saw complex. We saw character. We saw hello. So this is basic. So now we will just go a little. What are the operations available? Shall we? So we can play around. For example, A is equal to hello plus 5. When you do that, it is not possible. One thing was so if you want to concatenate, this thing is not available. There is a function called paste. You should give paste and zero. So you can't just use plus. This one is not operator overloaded. So you can't use plus to concatenate. On the other hand, similarly, what you can do is internally 0 is given to false and any other number is given to true. In R it is like that. Any number. You can see logical of if you give 5. If you say A, it is true. If you give A after logical of 0, it will be false. So okay, yeah. See here, A is app.logical of 5. When you see A, it is true. On the other hand, if you give A.app.logical of 0, it is false. You can see it in the environment. So these things will come handy when you are using machine learning. While we are analyzing data, we may need to normalize the data. At those times, these simple casting operations will be needed. Other important things is you can. I'll tell you when we are going to machine learning. For example, we first we'll go to structured data. Machine learning is structured data. That will be our first step. Okay. So the data will have is comma separated. For example, we take credit card fraud detector. For example, the name of the person, not name of the person, his age, his salary, his credit history, things like that. And finally, whether you can approve the credit card or not. That will be the training data with which we train the machine. For example, if some person doesn't have a salary, that will be null, zero, blank null. So in those cases, we must not have a null. We can't push a null inside the training data. At that time, we'll normalize the data. Either we'll replace the null with mean, average of the data, or things like that. So and those things are called normalization. We'll go through when we go to machine. So in those cases, this function will come very handy. So I was about to tell the difference between numeric and integer data. It is same as float, but always when you give when you declare a number, it will always be. Now you can see that. So A is equal to 5.5. Class of A is numeric. A equal B equal to 5. Class of B is still numeric. But if you want, now we'll cast both A and B to integer and see what is happening. So when we do it, this is happening. So before B was 5.5, right? For A was 5.5. When we converted it into integer, the 0.5 was converted. So this is what is happening. And then it will be casted to integer. Always it will be numeric. Only if you explicitly give, when there is decimal, you remove it and convert it into integer. So this is it. So this is all. This is the only thing that will be boring in R, because this is nothing into nothing. The next thing is really interesting, which is the structures, data structures in R. The presentation will be in a different format, the same presentation, which will be in a different format. Instead of switching the control between that machine and this machine, I open the disk. So these are all the basic data structures in R. Vectors, factors, matrix, list and data frame.
We have extended this 1 hour completely.
Okay. So right here, these are all the basic data, right? So we'll go to an example of these things. Okay. Today morning, I didn't have time, so quickly I did few examples and came. So So this is a vector. So a vector is nothing but an array. What other programming languages call as an array calls it as a vector. So a vector is the collection of homogeneous elements. If you construct an integer array, I mean integer vector, everything must be an int. So that is how we can do it. So how we do that is using the syntax. If you want to declare an initialize vector, we do this. Vector 1 equal to c of 1, 2, 3. So C stands for combine. So inside C you can pass like 1, 2, 3. If you are lazy enough, I mean like if you want to type that much, you can even type comma 100. So what I meant to say is it's infinitely overloaded. You can give comma as many numbers as you want. Other ways you can declare is so as you can see, vector 1 is numerical array of it has 3 elements 1, 2, 3, and the elements are 1, 2, 3, 3, 4, 5. So that is how it is given. For example,
Range you can give.
huh?
Range also you can give.
Yeah, that is what I mean. Vector 3 is
Database automatically.
it is automatically identified. If you want, you can also internally type that. For example, so as we asked now, I have given the range. Vector 3 is C of 1 to 5. So 1, 2, 3, 4, 5. Not that can run certain packages without even JVM it can run. I mean the basic R. So I didn't have the R basic things. I mean like how to install step by step. Maybe you can do it if you are having this. But I'm saying it is straightforward. Everyone is using Windows machine, right?
Yeah.
Mac or so it is very straightforward and everything.
After you can install.
Install R first, then R Studio. You need not even point the installation of R. R Studio will automatically take which version of R.
You need to install first or
First you need to install R.
Linux also you can.
In Linux you can install, in Mac you can install, but the format changes. I mean how we install it. If you are using Linux or something, if you use apt those commands. In Mac similarly you can do brew install. So here as you ask, vector 3 is C of 1 to 5. So and also it is being declared here. So before going to the next data type, let me show you something. If you just install R without R Studio, this is how your console will look like. This will just give you a terminal, as you can see here. This will have only this thing. You won't have an ID like the environment you saw, right? What are the variables? Those things will miss. But this one will have just this. You can also run when you install R, you can give R space filename.r and it will run that file. Things like that. For example, for deployment things you can use R, but for developing you can use R Studio. Okay. So now we'll play some more with vectors. Okay.
So we declare this vector, then for the next step.
We'll go to them. How we can index? For example, we need to access the third element. In R, the index starts with 1, not with 0. Other programming languages starts with 0, right? Here it starts with 1. So vector of 1 is vector 3 of 1 is 1. Vector 4 is 4. So we can one interesting thing about R is you can do negative index. Vector 3 of minus 1. So except my first element, it will display everything.
Oh, negative.
Yeah.
Negative in the first element.
Negative the first element. For example, without the fourth element. So 1, 2, 3, 5. We can do
There
this
also
like
can give range.
we can do it.
Alright.
So now try this. Let us try. Yeah, you can do it. You can do it. So this was the thing. Next is we have a named vector. In some conditions, we can't access everything by number. Correct? For example, we have months of the year, January, February. So internally, we can have months as 1, 2, 3, 4, 5. But it will also be good if we know that first month is January. Correct? So we can give names of vector 3 had a 3 name 3, right? So what here we are doing? So before we saw vector 1 as just 1 to 3, right? Now if you see vector 3, vector 1, it will have a named vector. You can access by the name.
Okay.
So vector 1 of A. If you give that, it will return 1. So this is called named vector. This will be really useful when you do text analysis. We have to internally convert the characters into a number. We'll encode it. So if you want to take what is the number, you can get it. So this is named vector. You understand this? You understood the syntax? It's straightforward. Names of vector 1 is A of 3.
What is the difference?
That is what indexing will be easy. Vector 1 of A. This will be more meaningful.
Accessing the data.
Accessing the data will be meaningful. For example,
Dictionary.
yeah, it's like dictionary, key value kind of.
But you want to tell 1, 2, 3.
Sorry?
Now it's automatically.
Yeah. No, it didn't take automatically take 1, 2, 3. Before we had vector 1 as 1, 2, 3. Okay, so this is the thing. There are lots of things to explore which can be done if you install R and R Studio. You can sit around and do lots of things. If you do, you learn more.
What is the average time to
Learn R. Drop away 3 months. No need for it. I will say 3 hours to 4 hours. You can do 3 hours. Basic programming can do it in 3 hours to 4 hours. For that, 1 week. If you dedicate like 3 hours per day, 1 week, you can start working. That is the advantage of this functional programming. It won't take much time. We don't have syntax, we don't have bar sizes.
Even Python also that's difficult.
Python is also.
any syllabus to learn before starting?
I would say interest. If you have it, you can start.
Microsoft has a function for rank of level sharp.
I'm not sure. Actually, I hate .NET and Microsoft products, so I've always been going around. But there is Scala. Have you heard about Scala? It is totally with Java. It is built in from Java. So I've used Scala, but not.
Microsoft has its own Microsoft.
Yeah, Microsoft R is there. It is similar to R Studio. Instead of R Studio, you can use Microsoft R. No. Scala is totally different. You know, there are Hadoop frameworks like Kafka, Spark, everything. Those are internally built using Scala. So Scala is more like Lambda functions. It's like simplified version of Java. It's written in Java. It shares the same JVM with Java. So Scala you can use it for those purposes.
Okay, guys, in the online, we are extending this program another 45 minutes of time. So just for awareness, I'm just informing. Are you okay?
So before going there, any more questions like this? Very interesting questions. So we'll proceed. So we'll go.
In vector, you have to name the vector.
Yeah, name vector. So we'll do some things like A. Sorry, I'm really obsessed with using the first variable as A. Please don't use that. Give a meaningful name. So what was vector 3? Here, before the vector 3 had a size of 5, but I named it with only 3 variables. 3 names, correct? Then the remaining will be NA. So in R, we don't have a thing called null, it will be as NA, not available NA. So again, we'll go to
Sorting or classification.
yeah, I can do sort. Sorting is done. Can do it simply in multiple ways. I'll tell you how to do it. So now we have vector 3 as 1, 2, 3, 4, 5, right? If you want to do operations like, for example, you are programming something in Java, and if you want to find which one is greater than 5, so what we'll do, we'll write a for loop, iterate it to everything, 4 lines, 5 lines, right? But look at here. So can you see what has happened? I just gave vector 4 is vector 3 less than 3. So what happened is everything which is less than 3 came as true, and everything greater than 3 came as false. So these simple things will save lots of lines of
For
code.
loops.
So
It's not for loops.
for loop is there. Sometimes we can't avoid for loops. That those for loops it has while, it has for, it has if else, but it can minimize. For example, so what happens is internally it has a powerful algorithm than a for loop. So we know algorithmic complexities, right? Asymptotic complexities. So for doing this, it will take an order of an O of n time, right? But here it will be much less because they internally have better algorithms to do this. So this is logical vector. This is how we can convert logical vector to this thing we use, right? Vector 4 equal to vector 3 less than 3. This will be using a lot when we go to another data structure called data frame. In that case, we'll be using this one a lot. So that's all about vector. These are all the basic things about vector. So what was the next data? Okay. Factors will go at the last. So it will be a little confusing. We'll go next to matrix list, then we'll go to data frame, then matrix list, factors, then we'll go to data frame. Cool. So what was the next one? So this is one of the many ways you can declare a matrix. You can initialize a matrix. So what happening is A is the matrix. What are all the elements? 1 to 20. The number of rows is 5. Number of columns is 4. So it will be a 5 cross 4 matrix. You can increase. So if you see the declared matrix. I gave 5 rows and 4 columns. So 1, 2, 3, 4, 5. For example, now you can see this one has entered column wise, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's like this, right? We can also change it as also here these functions are overloaded. If you want to have suggestions, you can give control space to give a suggestion. So if you give by row equal to true, see now it has changed. Before by row was false, default it was false. 1, 2, 3, 4, 5 it came as column by right. Now it became row. 1, 2, 3, 4, 5 column. So each thing it has a intricate functions to do this. Otherwise, To do this, we may do lots of for loops, right? We can minimize it with there. Yeah. If you want to initialize with just one value, for example, this was an integer matrix, right? If you want a character matrix, you can just give A. Now if you see A, all will be A. Okay, now we'll do one thing. We'll just pass in. So what we're doing is we're creating a matrix. It will have only characters A, comma B. No, not random. In parallel, A, B, then next A, B. So if you give now A, so A, B, A, B, then for example, same way we can play around with this. Instead of 1 to 20, we'll just give 1 to 10, but it will be a 5 cross 4 matrix. We'll expect that other elements will be null, right? It won't be null. It will go in a cyclic order. After 10, again 1 will start. So with this, you can do lots of matrices.
Example like what? How will you use that vector?
Yeah, those things will first we'll learn this. What are the right? Examples will go. Okay, I'll give an use case. Okay.
That's okay. We'll continue.
Sure.
Maybe that will go in the toolkit.
Okay. So now we have seen how to initialize, how to create an array, I mean matrix. Now we'll go into the how we can index the matrix. A of 1, comma 3. It is 3. Similarly, A of 3, comma 1, things like that. Now there are other cool things you can do. If you want to just give one first row, you can just give A of 1, comma. So you give 1, 2, 3. We will give the column. This column is one second column. So things like that you can do. Now if you see class of it will be an integer vector. It will be an integer, but it will actually be a vector. Even also a matrix must be homogeneous. It can have only everything must be of same data type. If you want dissimilar, if you want a dissimilar in an array, we'll go for this. If you want a dissimilar in a matrix, we'll go for data, which will be going. So other things you can do is, so what was the matrix? This one you had, right? Like how we did that time, we can also give a name for this row and column. For example, row can be actually what must be there is, if there is 5, we must have 5 names. Each one must have a row, correct? Yeah. Here this is row. Okay, I understood. We'll see this later. This is a good error. We'll see this later. So this was the matrix, right? This is how we add the dimension. So we had I'm really lazy to type. I can't type. Yeah, you just think. Even that will feel lazy after the time. So ours was a 5 cross 4 matrix, right? The reason why I am taking effort to, I mean, like show the simple things is the simple things will be using when we go to machine learning. At that time, when we do this, we'll be like, what is happening? So that's why this will be. Now, if we now we have added dimension names to this. So now we here instead of 1 comma 2 comma, we can it has a name. So you can access A by so we can access this. These things will be useful as if there was a data set like this. If you want to get the age of this one, salary of this one. So generally how the actual statistical data will come is we have 400 to 500 columns. We just can't remember the index of everything, right? For example, get me the 428 column. We won't know what it is. We have to look at the key or something like that. At that time, this will be really useful. Get me salary. We'll have that. We'll remember what we have named it. Just give A of salary. You can see everything. Here, all
All these are for structured data.
yeah. Unstructured data, semi-structured data, there are different ways to handle it. When it comes to R, we have to convert them into structure. So, for example, when we get a JSON, there will be functions like read JSON. So, we'll read the JSON file, then we'll convert it into data. When we have unstructured data like a text, like an image, we'll convert it internally into this data structure. Only if you convert it into these data structures, you can process it later. So, I just highlighted the topic in my talk. So next one is transpose and other operations like that. So we have A as matrix, right? If you want to get transpose of A, you can use P of A, matrix transpose. So okay, fine, right? It works fine, right?
Yeah.
Now we can do something like
Yeah.
next A plus A.
Okay.
So matrix addition. Now we want to do A plus, with a matrix you want to add a scalar A plus 5. So the scalar 5 is added. Now you want to add A plus A, we did it, right? One thing is, matrix multiplication. No, A inverse is different. There are functions to do that. Okay, if you want to have an inverse of a matrix, that must be square matrix. Correct?
Yeah, correct.
Those things, it has internal pre-built functions to do calculate. Those things you can, if you want it, I can show you. If you want inverse, you can press Okay, so next is matrix multiplication. So we'll try. Here it is 5 cross 4, right? A is 5 cross 4 matrix. Just try A into A. What is happening is 1 cross 1 mapping is happening. This individual elements are getting mapped. A was 1, 2, 3, 4, right? 1 to 1 multiplication. But this is not real matrix multiplication, right? So what you can do? I don't. I don't think it has a direct inverse. We need to have a function. There will be a package which I will be.
You can create custom.
You can create it. If you want, I can show you. Okay, later because I have it as a slide. I have planned it. There is a syntax for a matrix. There is a different symbol for doing matrix multiplication. Okay, percentage of it. Now if you do this, it won't accept because for being a matrix multiplication, 5 cross 4, 4 cross 5, that order must be preserved, right? So we'll create a matrix in that. So what is A? A is a 5 cross 4, right? So we'll create B is a matrix So it must be 4 cross 4. Eh? So it should be 4 cross 4. So we have A, we have B. So now we can do A percentage, percentage. So the matrix multiplication. So we ask for inverse, right? With the default base packages, it doesn't have that operation of inverse. There are ways you can download a package which will tell you. So this is matrix. Okay. Other than that, there is things called R bind and C bind. For example, R bind is row bind, C bind is column bind. So we have a matrix A. It has now we want to have a, for example, there is another matrix. We need to combine both of those in row wise and column wise. You can see. So C is R bind of A comma A. Now if you see here, row wise it is matrix. It is like merging two matrices. Okay. This is row bind. This is C bind. So here this is C bind. This thing will be used a lot. R bind and C bind will be used. This is the simplest way to merge two matrices. This will throw an error when there are number of columns in one matrix and another column, number of columns in another matrix within one.
Something like when we want to merge two CSV files.
Two CSV files. We'll have a what to say dependent variable, independent variable. We call it. If you want to merge independent variable, will come getting from another data. This is like a join, one-to-one join.
So instead of writing many lines,
Yes, yeah.
none is done through it.
No, it will throw an error. You can write.
The thing is, we have to process the data with all the non-values to have some default.
Yeah, correct. As we told, you asked whether it will throw null, right? If A and B are incompatible, if you ask whether it will throw null, you won't throw null, it will throw an error. Number of rows, if you do C bind, rows must match. If you do R bind, C columns must. Okay, as we asked, first step in data analytics will always be getting the data and cleansing the data. During cleansing the data, this small method will come in. My senior in my project is the actual machine learning just takes 5 minutes. The true challenge is in creating the data, cleansing the data, bringing the data into the format which you can consume with the data, and choosing the algorithm to. When we select all these things, this will take the maximum time. Actual application of machine learning will hardly take 5 minutes. There will be a function, take that function, put it, it will be done. So this is R and C one. We saw character vector. Similarly, there can also be a logical vector also. I mean logical matrix also. So true false, similar to that way. How is these things can also be. So anything else in matrix? Do you have any doubts? Doubts in matrix? Okay, now we'll go to the next. We'll go to list. List factors and data points will be. Okay, I told list Vector is a collection of homogeneous elements. List is a collection of heterogeneous. A list can have first integer, then a matrix, and then you can have a matrix as a second element. Third element, it can have a single logical vector, things like that. See here, I'm having a. So, what is the data type of n? N. What will be n? It's a vector, right? Vector of integer. Similarly, what will be the one for this one? Yes. Character vector. B is Boolean vector. Logical vector. Okay, everyone. Now we are creating a list of all these. We want to combine all these things into a single data format. That is named list combination. Three, just a number. I wanted to show that you can even send a single number. For example, next you can send it to. You can send a hello. What?
Class of X.
Where?
This case, class of X is
I'll show you. It is before we had a matrix, right? What is it? So now if you display X, you can see it. So you can see the first element is
how do you take that? That date field and all.
I can take. For example, it has a function called as.date. Similarly, you can format it and format it.
Okay.
For example, date before today is as.date of default format is year month date separated by hyphen or slash. You can write 2017 12 12. If you see date underscore today, you will come here. You can see class of date.
Now this will be given as a date variable.
Date
Right?
variable. So there is
We are
a
not with data type.
date.
Date is there.
Date is this, but this is not. It won't come under this primitive thing. Each people define date. I mean, like what it is. Since it is open source, there is no set of rules. Like this is basic, this is basic. So from where I generally go through, date was not referred to as people. So
We can do the date comparison on, right?
yeah, it is a class. Internally, it has multiple classes. Out of those, this one. Internally, this date will have a. I mean, like it's like any other. Also object-oriented programming. You can create objects, class, and everything. S3 object, S4 object, we call it. We'll maybe that is probably out of scope, but R has object-oriented programming. So this is a class. Date is a class, and it will have what we probably have is an object of the date. So he asked whether you can compare two dates. Date underscore today. Sorry, that was not today's date. We'll just do date underscore today. Less than hash dot date of. Tell me some other date. 2019 02 maybe 02. It will say false. No, that one is later. We can do our things like that. If you need a timestamp, if you need to change the format of this, there are functions to do that. So you can play around. So are you clear with this one? Okay. As dot. It's a syntax. For example, for typecasting, generally we use as dot. So it's going too technical stuff. Can I showcase what I did? Yes. Day before yesterday using R. I just used it. Everyone is using WhatsApp here, right?
Yeah.
So what I did was I joined a group. It was really irritating. For every 5 minutes, 100 messages came. I thought, why these many people are jobless? Let us see what is happening in the group. So there is an option called email chat. Have you seen it? WhatsApp. You can email chat.
Email chat.
You can email the chat history. I downloaded the chat history. I kept it inside R. Then I wrote a 20 lines of code and I came with insights from the group. I have it here. So the insights I came were like who are the most witty people? You know Tamil, right? So who are the most witty people? So I came up with a graph. Why this many people? Here this particular person has sent from the group was active for like 1 month. In this 1 month he has sent 2,000 messages. Then the day wise in each day how many messages were there. So hourly distribution at what time the group is more active. Here you can see time. So these things, these basic things from which we learn today, we can build this.
So how long you took it to do this?
It hardly took 10 minutes of coding, 20 lines of coding. 20 minutes, 10 minutes of coding. See here I created a word cloud. What are all the most commonly used words?
Okay.
Other things you can do is you can do sentiment analysis. How the group sentiment was, how positive, negative. Since these people start using English, we are not able to come. But if it was through English corpus, you can do it as maybe I can show it as a demonstration in the coming class. How to analyze what the context. I took the text. There was timestamp. It was there, but it was in a corrupted format. I mean, like unstructured data. So I had to use regex. I had to play around the data. Then I got it. Maybe I can demonstrate this as a demonstration in the class. It hardly takes. Maybe this will be like a hobby they can do it.
And they will companies will do this.
Yeah, sentiment analysis is different, but instead of doing for someone else, if you do it for ourselves and our group, it will be like yeah, we do this as a POC, okay? We'll WhatsApp analytics will do as POC. So what you people do is take one group message, take a group email chat, save it in your mailbox. So we can write. It will hardly take 20 to 25 minutes. If you are okay with the basics, it will take 20 minutes to do it. You can show off with your friends. See, I have done this.
What do you do in the images? You child
Yeah, there are two options in R. I mean, like in WhatsApp, you can say with attachment, without attachment. I say without attachment. Even with attachment, you can do it and process. Before, you know what I did? Now WhatsApp is using something called crypt12 encryption. Before it was crypt11. Our phone will have a key file. With the key file, you can easily access that .bat file, and we can access the SQL data. You can just write a query, select star from this number, and all those messages from the column. Before it was like that, but now with this thing, it got difficult. So I just email chat and I did it. So imagine the use case which we can build out of this. If you have a Facebook API, Facebook has graph API. You can just write a simple code to crawl the Facebook page, take all those Facebook posts from a group, you can plot a time. So also what I did was, I did a time series forecast. I was afraid, these people, the starting day itself, they started messaging 2,000 messages per day. I thought what will happen after 10 days. So I just created a forecast model. So that will also come under machine learning, time series forecast. So my prediction was like little wrong. So I thought it would be always increasing because the data suggested. But after some time, people got bored and so some things we can never predict. Those things are out of our control. So similarly, why I came to this is with we can also do time series analysis using machine learning. Before we are talking about machine learning applications, right? So one such application is time series data. For example, what will be the stock market prediction? No people have been able to do it perfectly, but still researchers are going. How to predict stock market data? How to forecast weather? One perfect use case for time series prediction is there is a website called data.gov.in. Government of India releases data of many data. It has terabytes of data. One such data is price of ladies finger versus month. It has daily data of each month of ladies finger. When you see for the past 5 or 6 years, the time series will be like this.
Price of gold is also
Price of gold is also. So how it will be? It will be like this. If you see here, this will be here. So the overall, the price is also increasing. At the same time, seasonally the price is increasing. So these things, when we see just the number, we can't understand anything. But when we see it as a graph, we can predict it. So there are many time series models like ARIMA models. Are there. So with that, you can predict what will be the price of this figure at this point of time. So you can see the price of this figure at that point of time. So these things we need not go for data. For learning purpose, these things are readily available. How many of you know Kaggle.com? Yeah, Kaggle is there. So in Kaggle, there is lots of data sets. Recently, Google acquired Kaggle. So there are lots of data sets. If you are participating in Kaggle contest, Google Cloud is we are also getting a Google Cloud offer. So what is Kaggle is? From beginner to expert, they have wide variety of competitions for money. I mean, like they will give you the data, they will ask you for insights from the data, they will ask you to predict. So in that cases, there are lots of learning data, simple data. One such data is Titanic data. Here, it is an evergreen data. What is it? It will have the passenger detail of all the passengers in Titanic. What was the range?
even if you go to the tableau.com, the first page is
Okay, tablet. So just how like Hello World program is for programming languages, we have two data sets for machine learning, which we will always use for learning purpose. One is that Titanic, another one is that Iris data set we call it. That we'll use it most commonly. We'll see Iris data. We'll play lots around with Iris data. Okay, let me tell you what is the Titanic data set. You will have passenger details like age, how many, whether that person is married or not, whether that person had a sibling or not, things like that. So when we play around with the data, we can find that the guy who is single literally alone died. A lady, she has escaped. 70% of the ladies have escaped. So from that you can understand. Just by looking at the data, you can come to conclusion. With that, you can build a model. With that, you can predict if you are going in another ship. If you are a guy, you can predict your own self and you can take your insurance. Whether you survive or not, you can take it. Things like that. So that is what I'll probably show it. I'll take a structured data and I'll show the summary. Average age, how many male are there, how many female are there. We need not code everything. That is there is a function called str, summary thing aspect. So what it will do is it will give the summary of the entire data. So how can we proceed? We'll go see more about the data pictures, or I'll show you the data. You'll see the data, right? Because these things you can easily Google and learn. Even if I say something, I will say only 10%. These are all really simple. Okay, for example, we have a Iris data which is preloaded. So this is the Iris data set. What this Iris data set is, there was a jobless person at some point of time who went into forest and collected flower species called iris. He went, there was thousands of flowers. He went and measured the length of the sepals and petals. See how jobless people are. So that is his data set. We have the sepal length. Petal and sepal is like botanical terms. We have a flower. We have a flower part and a green part, right, at the bottom. So that is sepal and petal. So petal is the flower part and the sepal is the green color part. So that is the data, and here classified it into if it has He knows that this one is Setosa. There are, I'll show you. So we'll see summary of thyroid. Here I told you, right, there is this Titanic data set. With just a single line we can get the detail about all the things. I just give a summary of the thyroid. See here it is saying the minimum length is 4.3, maximum 7.9. Here we are getting so much statistical information. Yeah, you can show it. Plot, I'll show you the really basic, most basic plot, okay? Okay, see here. Okay, I did data set, right? This is this flower. You can see any flower will have actual flower part, and below there will be a green color stem kind of part. That is better, so we can pass it around. So this is a sample plot. This one they call it as a box plot. There are multiple plots you can do. I'll show there we can allocate separate classes for plotting. So this is a simple plot. You know what is the box plot? Okay, box plot is, for example, if you have a data, you will construct a box plot. You can have like three components. This will be the minimum, this will be the maximum, this will be the average. So that is so it is like all the data like sorry, this is minimum and this is maximum. This is minimum, this is maximum. This is first quadrant, this is second quadrant, third quadrant, fourth quadrant. So those things you can do. The minimum is 4.3 and minimum was 4.3, 4.3 is here. First quartile was 5.1, maybe somewhere around here. Okay, from this graph itself, you can basically understand something, right? What we can understand is Setosa generally have a small sepal length. The second one is vesicular, I guess. It has comparatively longer. So from this picture you can understand, right? It is increasing. Similarly, we can plot it with another. We can plot with another parameter. There is something called scatter plot. I will show you later. With that, we can compare each parameter with another parameter. It will be like a 2 by 2 matrix in which full of graphs. With that, we can compare each element with another element. So, what is this iris data set is? When we have now we will train our model with this data. We have this entire thing, right? This species, Setosa. So now in future, another person comes and comes up with a measurement. He finds a flower, he will measure what is the petal length and sepal length. And if he feeds it into the model, we can know whether it is what it is.
What is called?
Site where we can download data different
Conduct,
Yeah, they conduct competition
last one they conducted for 2 lakh competition for machine learning. They give some sample. Who is writing the best one will get 2 lakh.
that thing will happen every week.
Every project there. I mean, every project they have money. Competition. So the competition will they have. Huh? Solve is another website. You can you can also
Why this one is not nice?
just go over the control line. Google Chrome itself, for example, control line, control zero. You just selected this. It was made extend on the double zoom. Maybe then function okay. The page goal is now and be able to see the screen. Is there anyone knowledge or but is a drag and drop? No, we just need to drag and drop something. Mouse or camera. No computer there. Handle one. Mouse. Training. After go to meeting, you need to access this. So second step of the extension. So he is access. Yeah, but in the screen is other person from but the minimize இது என்னால ஆக்சஸ் பண்ண முடியுது பிரசன்ட் என்னோட லாகின் பண்ணிருக்காரு இது என்ன உங்களுக்கு இல்லை இங்கதான் இருக்கு ஆக்சுவலா உங்களுக்கு நீங்க டைப் பண்றீங்க நீங்க உங்களோட ஆக்சஸ் பண்றீங்க
So, yeah, the Titanic data. This is the Titanic data set.
There is no shape for that.
Google access only.
Yeah. So this is the Titanic dataset. These are all the various attributes available. Survival is whether that person survived or not. Ticket class. This is the class. What we've done. So different types of data you have. So these are all the various factors. I mean, like if it is class, there are three classes: upper, middle, lower, age, and this will also have whether, as I told you, spouse is there, sibling is there. So what I would suggest is, everyone, you go home, download our studio, download this Titanic dataset. As I told you, load the Titanic dataset. I guess it is already preloaded.
So what is the model type of the data?
I mean, KB. Yeah, yes. We have Titanic data ready made. We did not go to CAD. So we have a different class. This is a simplified version of the Titanic. That Titanic has a lot of data. This one has only 4 parameters. First class, male, age is this one, survived or not. We'll just see summary of Titanic. Okay, these are the things that are important. So, as you saw, there is first class, second class, third class, and crew, age from male and female, child or adult, survived yes or no. This is simple version. On the Kaggle, we have a much more complex version. Where did he go, whether he had children. So, what I suggest is use this data and come up with inferences. First, take only the class and see how much people survived. These are matrix, right? Similarly, you can see. Keep x-axis as what is it, class, and y-axis as whether he survived or not. See how many people have survived in first class. So with that, if you do, that is the first step in machine learning. First, we have to analyze the data. We have to see what kind of input we get. Then only we can suggest which model we can use. So when we do this, we'll come to know. We'll have a first basic knowledge of what is actual data. So anything we have doubts? What is actually happening?
What are the other domains that we can apply this if I don't like statics?
Okay, like that.
There are things, there are two things. One is like industry related, where we can apply all this stuff.
Okay.
For the industry related problems.
Okay.
The other thing is where we can play.
We can play. I'll tell you a real time example. My friend owns a startup. Okay, he it's retail. He creates a point of sale for supermarkets and everything, and make them do online. They can do online just with a few steps, but provided they have their inventory. So what they have is he collects the data from them all, and he provides insights, real time insights, like which product is being sold more, which product needs to be added, restocked, what is the forecast of this product. So various insights we can provide. That thing is done using R. So similarly, in retail domain, it we have it. Similarly, whatever domain, insurance domain, there are multiple ways. From this data, you can say, okay, you want an example for using R and data analytics or machine learning? R, right? So R, you can, as I told, that one you can use R. Similarly, for everywhere we have data. Wherever we have data, we can use R. That is the most diplomatic definition.
See, like for the genomics data, they got all the plots.
Correct. Genomics data, they are using R.
Now it's like after Sunday I'm going to get a personalized message.
Correct. For each those things are being done.
That will be done in R.
R.
Nowadays, like if you go to a shop, they will take your blood test. Even if you want to modify your, you take your blood, find your genomics pattern, and
But if you touch the back end, it is matching your back end. That is the logic for you. That is the technique. Yeah.
First, we talk about the functional programming, conventional and functional. So, in general, conventional programming language has some use concept and all those things. So, if this is going to be the future,
Okay.
What are those kind of stuff?
We have, this is OOPS complaint. R is OOPS complaint, Python is also OOPS complaint. But we don't, we can, I mean, like, for day, when we use OOPS complaint things is, when we want to package it, deploy it, when we are going into production, those times we need OOPS complaint. Here, what we are going to do, just take the data, model it, we are going to come with it. So, generally, data analysts won't care much about the OOPS.
So, this is something like a using tool.
Using a tool, correct, exactly. So, but it is also out complaint. For example, we downloaded a package. If we use a package, that will internally be a class that will be packaged. So we can do.
If you go to the machine learning,
Maybe opening in your
yeah.
sorry.
Online down.
Great.
Yeah.
Okay. Okay.
Okay. So it was very interesting, right?
Okay. So these are like the buzzwords in the AI thing. These are the tools which are used. So TensorFlow is Google's product. H2O now Google has acquired it. H2O was done by Stanford, I think. Okay, Stanford. Spark MLib is there. Apache code. Then we have a Cafe which is given by Facebook. Mahout is also an Apache thing. I guess Piano is like what is it? It is a simplified tool, with which you can program both TensorFlow and Cafe. TensorFlow generally tends to have a complex syntax that it can reduce. Piano is there.
Yeah.
Piano. So it does that. Torch and Keras is there. Similarly, there are other programming frameworks like deep learning for J, deep learning for Java. It's like that. We have these are the trending. So these, among these, TensorFlow, Piano, Cafe, Keras, Torch, these are all deep learning frameworks. So whatever we saw, the way of model building is completely different when it goes to deep learning. Deep learning uses something called neural networks. Anyone have basic idea what is neural network?
That your brain is your neural.
What we are doing is we are trying to simulate our brain, create a model of our brain. We'll model our brain here. On paper, we'll model our brain and we'll train it. Like how our mothers taught how to read, how to write. Similarly, we'll teach. So those things we call it as epoch, EPOCH. We'll keep on training it. We'll first teach something and we'll evaluate that. So that thing we'll call it as backtracking and feed forward and back propagation. We'll do those things and we'll come to know. will try to reduce the error in which the model is learning. So those things is deep learning. Maybe we'll have this as a supplementary, additional. My area of interest is tensor flow, so we'll see some real time applications.
We have now machine learning. So it's like machine learning, deep learning, then AI.
Yeah, correct. With machine learning also comprises of deep learning. Deep learning is also part of machine learning. But generally, yeah. But generally, what people consider is machine learning is just regressions and classification. They, since these are new, there is no benchmark definition. It is up to how we understand.
One of the examples you said we get some F for the which you said it does not a character.
Sorry,
You said some examples.
what's that?
Not one.
Bank, credit card.
So the analysis was not correct.
That's it. What's the problem? Correct.
That can be solved through deep learning.
Deep learning.
Because
Not exactly. Yeah, it can. Provided more data.
The production.
Correct. We can do it. Deep learning will. So what deep learning is? It is a black box model. We can. We don't know what is happening inside. It is so complex that even we can't realize what is inside. So that will be really interesting. We'll go to deep learning.
Is it conceptual or is it really deep learning?
It's actually deep learning.
Well, the we learned that.
Okay, we'll end it with that.
Okay. So finally, I want to just tell a few more information about our meetup coming training session. And just open that for a quick in a minute. Is it your web is completed? No, open it. Start opening here.
ஹைட் ஆயிருக்கனால யாரோ சென்ஸ் ஆகுது. இதை க்ளோஸ் பண்ணு.
என்னோட கம்ப்யூட்டர்ல
இல்ல நான் என்னோட நான் பண்ணிருக்கேன். ரிமெம்பர் பண்ணிருக்கேன் நினைக்கிறேன்.
Where is the mathematical presenter? Vijay, right? Yeah, are you able to see my screen? What is the screen you are able to see? Is it presenting? They are presenting what? How to make a present? இல்லை இன்னும் ஜாயின் பண்ணியோ அவர் பண்ணி தான் வச்சிருந்தேன் Are you able to see my screen? What is the screen you are seeing now? Not sure.
Still it's blank for me.
Okay, we'll talk about it. Okay, I'll just brief about the upcoming sessions, what we have on the Big Data chapter. So we have, guys, just settle down. So we have 4 programs we planned for on a classroom-based session. It was on June 3rd and 4th. June 3rd and 4th. Sorry, June 3rd and 4th. It was Tableau session. It was organized in the classroom-based session. It is available in the conducted the quality subject. Okay? That location it happened. After 3rd and 4th, you'll have a continuous class on 5th to 10th, 5th to 9th, that particular week. You have a continuous class on every day, either by morning 7 to 9 or evening 8 o'clock to 10 o'clock. That slot you have a session on the Tableau. So we are going to cover on the Tableau and then 2 other topics. What are that? Power BI and Quick Click and Quick Sense. These 3 topics will come in the follow-up sessions. So other than that, we have the 10th and 11th, the machine learning session. It's all about the end-to-end of classroom-based programming-oriented session. We cover on the R programming, Mahou, Spark MD, and then we have the IO, H2O, then we have Transflow. So these programs will cover under the particular session of 10th and 11th, and then 12th to 16th, that particular day. And 17, 18, we have Hadoop Developer Certification, which is cover the 4 days of program, 17, 18, 24 and 25. With 4 days of 4 days of weekend program and 4 weekends of follow training. Okay, that will come till the July. 4 weekend, that will you will get a certificate program for that on all the program, machine learning, Tableau, and then Hadoop Developer Certification. Other than that, we have one more training program called Python Certification Program. Training program, it is starting from the 10th and 11th, and then 25th. 10th and 11th is the online full-length program, and then 25th is a classroom-based program. So that's where it will come. So under we have 15th and 16th, and then 23rd to 24th. In between the 4 days of program will come under online. So it is almost 4 days of classroom session. They will convert as an online Python program. Rest of the machine learning, 3rd and 4th is the classroom based. 10th and 11th is the machine learning. 3rd and 4th is Tableau. 24th and 25th, 17, 18 is the Hadoop Developer Certification Program in the classroom based. So everything is a purely hands-on based training. The experts will come and take the training on the each field. Some people expert on the Mahou, they will take on Mahou. Some people on machine learning Spark, they will take the machine learning. Some people are expert on the Tableau. That expert who is already at the real-time experience last 5 years, 10 years, who day and day basis they are working on that people will take the pure hands-on session. So that was the one of the message I want to pass. And also this big data chapter is now growing to the global level. So many people are joining from Singapore and then US and UK also for this training session. And then the people who are going to train also is going to connect from the an expert level, follow trainings will be connect from the other locations of other countries. This big data chapter is more than 5,000 to 7,000 people are there across Chennai and India. So now it's fastly growing. So these 5,000 people are in the meetup.com. So meetup.com, you can just go to the meetup.com, Big Data Chennai chapter, Big Data India chapter. You can just, if you want to refer your friend, you can just inform that your friends to increase the knowledge in this field. Ask them to join over there on the meetup.com. Ask them to join on the WhatsApp group. We have around 12 different WhatsApp groups on each different area. Machine learning, we have different WhatsApp group. We have a Tableau, we have different WhatsApp group. We have Adobe Developer Certification, different WhatsApp groups. Big Data chapter, we have different WhatsApp group. India chapter, we have different WhatsApp group. Job searching group, we have separate WhatsApp group. As we join, so that many people who are available on the same field, they will share their knowledge, they will discuss more on it. This is how we are running the community chapter for connecting across India, across the global of many people in one single place. That's it all about the Big Data chapter. Just spread your knowledge, learn many things, and share the many things to the community. Okay. Thanks for understanding. Let's meet on the next video. Thank you. Thank you all.